Here we have a SAT math problem. Okay, let's go to the question. C of x equals to 200x positive 150, R of x equals to negative 0.5 x square positive 600x positive 100. In the equations above, a company produces x units of a product per month, where C of x represents the total cost and R of x represents the total revenue for the month. The profit is the difference between revenue and the cost, where P of x equals to R of x negative C of x. For what value of x will the company create the maximum profit for the month? Okay, here this P of x represents a profit that can be found by finding the difference between the revenue R of x and the total cost C of x. Since we have to find the output, that is the value of x for which the company's profit is maximum, let's get the profit function that is using this equation. This P of x equals to R of x negative C of x. So for R of x, we have the stuff over here. That is negative 0.5 times x square, positive 600x, positive 100. Okay, negative, and we have to consider the total cost function C of x. So here we have the stuff that is equivalent to C of x. We can plug in this 200x positive 150 for C of x over here. Then we have 200x positive 150. Okay, here the profit function P of x equals to, we can remove the parenthesis over here, then we get negative 0.5 times x square positive 600 times x positive 100. Now we can distribute this negative sign to this one and this one, then we get negative 200x negative 150. Okay, P of x equals to negative 0.5 x square. Now we can combine the like terms. When I combine this positive 600x and negative 200x, I am getting positive 400x. And also we can combine this positive 100 and negative 150. I am getting negative 50. Okay, here I got a function which represents a profit, that is P of x. And we have to find the value of x, that is output, for which this P of x is maximum. Here, P of x is a quadratic function, and when I sketch the graph for this profit function, that is for this quadratic function, I'll be getting a vertical parabola. Since the leading coefficient is negative, that is negative 0.5, we'll be getting a parabola which opens down. So this will be the graph for this quadratic function we have over here. And since the parabola opens down, we have a maximum point over here at the vertex of the parabola. So here at this vertex will have some value for x, and the y coordinate over here will be the value of this P of x. Instead of y coordinate, we can write P of x over here. So here P of x, the profit is maximum at the vertex over here. So our aim is to find the value of x for which P of x is maximum. So that is we have to find the x coordinate at the vertex of this parabola. Okay, here this quadratic function is in standard form, that is ax square positive bx positive c. In that case, there is a formula to get the x coordinate of the vertex, that is x equals to negative b over 2a. X equals to, here we can take this negative as it is, and the value of b is the coefficient of x. Here the coefficient of x is 400. We can plug in 400 for x. And 2 times the value of a is the coefficient of x, that is negative 0.5. Okay, let me plug in. Then x equals to negative 400 divided by 2 times negative 0.5 is negative 1. Here this negative will cancel. I am getting x equals to 400. This 400 is the x coordinate at the vertex, and when x equals to 400, the profit P of x is maximum, and we find this value 400 in answer choice B. The correct answer choice for this question is B.